Hello there and welcome to Lower 6 Maths A-Level. This is the Applied Practice Paper I, and here we're working on question 7, a variable acceleration question. So a body moves in a straight line such that the velocity v meters per second at time t seconds is given by v equals minus a third of 2t squared minus 9t minus 18, where t is greater than or equal to 0. Find the initial velocity of the body. So initial is the key word here, probably referring to the fact that t is going to equal 0 here. So all we need to do here is just plug the value of t equals 0 into v. So v of 0 is just going to be minus a third of 0 for this part here, add 0 for that part there, and then minus 18 because that doesn't have a t in it. So when we expand the brackets here, this is going to be 6 meters per second. Okay, so fairly straightforward so far. Find the value of t when the body is instantaneously at rest. So if a particle is at rest, then v equals 0, and we want to find what t is. So all we need to do here is just set v minus a third 2t squared minus 9t minus 18 equal to 0. Now what we can do here is we can grab our calculator and get the calculator to do the brunt of the work for us. So expand in the brackets and we're going to get minus 2/3 t squared plus 3t plus 6 equals 0. So yep, plug that into your quadratic formula solver. And your first solution here is going to be t equals 6. And t equals minus 3 over 2. But given that t is greater than 0, we'll just ignore that solution there. Okay, part C, find the greatest speed at which the body in the first 7 seconds of motion. Now what we can do here is we can carry on pressing the equals button and sneakily complete the square of this velocity curve here, because remember, if we complete the squared, it's going to be a negative t squared graph. Then we're going to find the maximum velocity at the turning point. So if we just carry on, the t value here is going to be 9 over 4, and the maximum speed is going to be at 75 over 8. Okay, I don't think the question is going to want us to do it that way because it is giving 5 marks away for this question, so I don't think tapping a few buttons on the calculator is going to get us those marks. So find the greatest speed. Now when we find the greatest speed, this time acceleration is going to equal 0. So let's approach the question from that way instead. We're going to want acceleration to equal 0. Now remember how we get from distance, velocity and acceleration. Distance differentiated will give you velocity, and velocity differentiated will give you acceleration. And you can work your way backwards by integrating. So what we need to do in this question here is do dv by dt to get acceleration, and the acceleration here is going to be minus 4t over 3, and this one here, expand it and you're going to get 3t, so it's just going to be plus 3 equals 0. I hope this has made sense. I've jumped over this bit here. Greatest speed is when our particle has reached its maximum speed. It's slowing down to the point at which it's now not accelerating at all, and now it's starting to decelerate here. So when our acceleration is equal to 0 is when it's at its fastest. And when it starts to decelerate, that speed is going to decrease. So we want to catch it just on the point where its acceleration is changing from positive to negative. Okay, so greatest speed, acceleration is going to equal 0. Solve this equation here, and we're going to get 4t equals 9, so t is going to equal 9 over 4. Is that what we got for the previous bit? 9 over 4, good. But we don't want that. We don't want that time. What we want is the speed at that point in time. So v equals minus third of 2 times 9 over 4 squared. So plugging this back into the velocity function. And here, grab your calculator, and we're going to get probably what we got back here, 75 over 8. Okay, so that's what you need to do on this question here. It's going to be meters per second, and it's going to be the greatest speed. That's positive already, so we don't need to change it from negative to positive. Okay, that's great. That's 10 marks for that question.